Yes, the custom front spindles are finally done. Welcome to episode 17 of my all-wheel drive Mustang project, Project Traction. Another major milestone in the project. I have the front spindles done. After literally a couple of years of planning and CAD and grinding and making practice parts and 3D printing, I have both front spindles done, which is a major step. And so I'm going to go through a little bit of the background on the design process and then how I fabricated them. And so it's going to take a while, so let's get right into it. I mentioned in an earlier video how I really wanted to try to keep the S550 Mustang's original dual pivot suspension and not switch to some Subaru spindle or some other simpler spindle. But I wasn't confident I could machine all of the appropriate angles to replicate, the two ball joint connections and the tie rod. And so I very early on tried to lay out concepts where I basically took the stock spindle and cut it up and either bolted or welded a piece to it to try to make it easier. And in this early version, this is still using a scanned model of the base GT spindle versus the Magnerite spindle I eventually used. And this was just a proof of concept to see could I get it all to work out. But I didn't love the connection scheme between the regular GT spindle and going to the MR spindle seemed way more robust, and so I dropped this idea and moved on. Once I realized the Magnerite spindle was a better starting point, I spent quite a bit of time in CAD laying out an attempt at making an aluminum version, basically a CNC aluminum part or a series of parts that would bolt to the remnants of the MR spindle. But I was never quite happy with the attachment between the aluminum part and the MR spindle. There was only the 3 bolts, and it was kind of hard to sandwich it, and it was tough to fit enough nuts. I didn't trust using aluminum threads, and for various other reasons too, I quickly soured on the idea and tried to come up with a different solution, and that basically was a steel solution. Here you see a CAD model of an early version of what I ended up with. So basically you have the remnants of the MR spindle in the bottom, and it's being sandwiched on both sides by steel plates, which I can get simply laser cut. And between a bunch of just simple laser cut steel plates and some machine spacers, and then a machine spacer between the hub and the sheet metal, it becomes pretty easy to make. Also, the parts can be just flipped around to go from left to right. They can be the same part. There you can see there's a simple machine part to accept the ABS sensor. I'm using an ABS sensor from a 2015 Ford Explorer, which should work well with the rear Mustang hub. I thought to myself, another big advantage of the steel versus aluminum concept is that if I could weld to the remnant of the MR spindle, I could basically reinforce it even more, not just rely on bolts. It'd be welding end bolts. And so to prove that out, I took a chunk of a spindle. I was already fairly confident that it was steel. The documentation says it's steel. I did a spark test and I machined a little bit of it, and it's clearly steel. And I also then took this piece of 1/4-inch steel. This was straight, and I purposely just buzzed it on with the MIG welder without even trying very hard, and then proceeded to bend it over with a sledgehammer, and as you can see, it's just fine. Well, that kind of sealed the deal that the steel direction was the way to go. After laying out the different concepts in CAD, I proceeded to make a couple generations using a 3D printer. This was a huge help, and I can't believe I haven't done more 3D printing in the past. Between this and the shifter and a few other parts, the 3D printing has been a godsend. Here you can get a better idea where, so this is the existing spindle, and it gets sandwiched by 2 sheet metal parts, and then basically where the spindle hooks onto the strut, there's some more sheet metal parts with spacers that kind of interlock into some tangs here, and then there's a machined spacer that gets welded, and all this can be welded together, is the idea. A couple issues with this first concept is I need to raise the strut up a little bit more. There's actually the boot can rub a little bit, so I raised it up a ½ inch in this example, and I'm going to raise it another 1/10 of an inch to get plenty of clearance. Second is I was trying to divorce these two bolts because the radius isn't quite right, and I realized this bolt is too close to the CV joint no matter what. So in the next generation I reclocked this to have this bolt go through the existing remnant of the stock spindle. One issue I have to address no matter what is I won't be able to use these standard CV boot clamps, excuse me, because these bolts here, which are, you know, the radius of where these are relative to the wheel center line or the CV joint center line, are set by this hub. And you can see with this being so thick, which is good from a strength standpoint, this hits, right? Another reason why I'm going to get rid of this bolt and just rotate the hub to have this bolt replace this one and move it out, and this machine basically it's about a 60,000 slot in the existing spindle base to get more radial clearance. So I'll have to get some earless CV joint boot clamps so that doesn't happen. Here you can see there's plenty of clearance between the ball joint and the CV axle with the basically 1-inch drop. You know, I raised the center line of the wheel 1 inch from the stock location. After finalizing my design in CAD and the 3D printed parts, I proceeded to make an order with Send Cut Send, and I have to say the parts are pretty impressive and worked out pretty well. Next I had to machine all the spacers. There was 14 of them, but it went really fast. They're all basically the same, you know, face off the end, drill the hole, and then use a groove tool to cut them off and put a little chamfer on them pretty fast. Next task was machining the 4-bolt spacer that goes between the hub and the main body of the spindle. So I cleaned up some stock and I laid it out in Fusion 360, well originally Creo, and then imported in the Fusion 360 and used that to set up the tool path and started making a lot of chips. I thought about having the outside of this water jet, and that probably would have been a smart idea. Send Cut Send doesn't do that. It would have saved a lot of time, but to be honest, I haven't done a lot of steel, and I kind of wanted to see how this would go. Using the 3/8 carbide end mill, it went perfectly fine. It munched through the steel, no problem. And it took probably about an hour per part, you know, maybe an hour and a half to be honest, and then there was 2 parts, so it wasn't too bad. Basically do the outside profile, put in all the holes, put in the center, and then basically get it ready to be flipped over, all of which was laid out in Fusion 360 and was a pretty easy task. Top operation is completely done. Now we just got to flip it over and get rid of this flange and machine it to the proper thickness, and we should be good to go. Had to show off my new toy for the milling machine. I bought a probe. This is a DrewTech, and have it incorporated into my Centroid all-in-one DC controller that's been retrofitted to the mill. And this is one of those things, once you have it, you can't figure out how you lived without it. It makes this so easy. And you can see in the next step when I had to redo the profile on the outside how the matchup was perfect. It repeats within a couple tenths, half a thou for sure. It's pretty amazing. The piece of stock I used wasn't quite thick enough to get the whole profile or the full height of the profile in the first operation, so when I flipped it over I actually had to do a profile cut to machine off that lip, and as you can see with the probing, the mismatch, it's really undetectable. The part turned out great, even though it'll all be covered up with a weld. It was kind of fun to play around with. Next up was making two holders for the ABS sensors. Pretty simple part, couple holes, one for the body and one for a threaded hole for retaining it. The last operation was machining the actual spindles. We ended up not using the fixture I showed in a previous episode and simply used the vise and some clamps to get it rigid. The fixture caused a few issues and it was actually just simpler to put it in the vise. The first operation was basically done by hand, and it was the removal of 400 thousandths of material to get the stack up to work correctly. Then we proceeded to basically add the clearance for the CV joint. We started out with a high-speed steel tool, but then switched to a carbide tool to speed it up a little bit. And this basically provides the clearance for the CV joint with the 1-inch drop built into the design. The last step was adding the slot for the clearance for the one bolt that was mentioned earlier in the video. And here's one final sanity check using the sheet metal parts to make sure it all lined up. And as you can see, it all turned out great. Here's the part out of the mill. This is the passenger side piece. Basically, this has been shortened, this has been opened up, and this has been cut away by the mill. And the rest of it has a little bit of more of a bandsaw type operation, so it needs to be cut off right here. You can see when it got milled that it busted through, which is good. So I just got to cut it off here with a bandsaw and do a little flapper wheel action to round this out before putting the rest of the components back on here and getting it ready to weld. Here are all the parts laid out. Cut off that little bit of extra material and blasted the spindles, and got all the laser parts, machine parts, and everything ready to go. One last minute mod was chamfering the spindle for better weld penetration. This will give you kind of an idea about how this all relatively easily bolts together, utilizing a couple of the existing holes on the original spindle, and then all the spacers and laser cut parts. It all really worked out quite nice and kind of falls together like a giant jigsaw puzzle. So the spindle's all cleaned up, it's been chamfered, and it's ready to start getting tacked together. I got the main structure tacked together, so I put on the parts for the brakes after a little bit of massaging here, and I'm going to tack all that together so I could, when I put it in the car, I can put the brakes on and make sure everything's good. I went a little nuts with the tacking going on in the MIG welder. I basically did everything that you ultimately won't be able to see, that'll be covered up once I put the outer plates on. You probably could actually drive the car like this instead of a little overboard, but it's all looking great, and this is a major step, so I'm excited. Here's the first mock-up in an actual wheel after doing the initial tack together. I have an 1/8 inch spacer here. These ground control struts actually have a slot in the upper section, and then there's a little piece that goes in there where you can either have it centered or flipped left and right to get more clearance. I don't have that in there right now, but it looks like with the centered version, which was my original intent, it'll actually be a little higher than this and clear with more than an eighth of an inch. And this was with the 295 35 tires, 19 by 11 wheels with 50 millimeter offset. And so I built in 15 millimeters into the whole new custom piece here. But as you can see, it's all looking pretty good. Next step is to get it in the car and probably not put weight on it, but get it in the car and just look at the angles. Doing kind of a little investigation on CV axle angles here. Hard to get the right light here, let me see. But this is the tacked together front spindle with the strut at ride height. And you can see this is basically the rear CV joint of the Mustang. I just cut the shaft. I wish I would have made it a little bit longer. And this is the steering wheel all the way turned to the right, which is the worst case scenario. And it looks like it's going to work. It's a little close. I have a little bit more angle. It doesn't necessarily want to go there. But it looks like I have a little bit more to play with. Obviously, you don't want to turn the wheel all the time this tight, and we could put some limiters on the rack. But it will for sure need a new boot. In the rear of the car, they use these really stiff plastic boots, and I'll need to get like a rubber neoprene boot to handle the angle. I had to take the clamp off to even get it to go this angle. But looks like it's going to work. I am going to move the diff forward like a 1/4 inch, which would help a little bit more. The mock-ups look good, so I started burning everything in for real. First with some tacks, and then more substantial welds. One last thing was to put in the ABS sensor mount. You can here it is with the actual sensor bolted into it to check for clearance. You can see how it just slides into the 2 slots in the sheet metal parts, and then how it can be positioned to detect the magnet in the back of the hub. The final thing was boxing everything in, and I had basically laser cut little tabs on these that interface with some slots on the main 2 sheet metal parts. So those were burned in, and then a little flapper wheel machining, some black paint, paint it black and put it back, and they turned out pretty awesome. Now, you're probably thinking to yourself, how much does all of this steel weigh? Have I added just tons of weight to the car? And, I estimated some of this in CAD. It got a little heavier than CAD would suggest, but you'll see it's actually not that bad. So I got a scale right here. And here is a regular GT spindle, right? Not the Magnaride spindle. Let me put that on the scale. And we're at about 18.8 pounds, so pretty light. We then go, and this is as apples to apples as I can make it, right? So I have the hubs bolted on, no dust shields, nothing else, just basically the hub and the spindle. We then go to the Magnaride spindle, and it's quite a bit heavier actually. It is known to be stiffer, that was the whole point, but 22.78 pounds. So what is that, about, you know, roughly 5 pounds more? But that was done on purpose to make it stiffer. Well, then here's my, looks to be massive four-wheel drive behemoth here. And excuse me. And it is 23.76. So about a pound more only. And it's quite a bit, you know, quite a bit taller, as you can see. So the whole hollow construction worked out pretty well, so I'm pretty excited about that. And I had a little surprise here. I found a good deal on eBay. I ended up finding just a smoking deal on these two-piece rotors, which are 11 pounds lighter than the stock Performance Pack 15-inch rotor. And so that should basically compensate for the heavier, 1 pound heavier spindle and cover, I think, most if not all of the CV joint and the axle to keep the weight down, slash at least the unsprung weight should be about the same. So I'm pretty excited about that, but it's all working out pretty well. Well, that's a wrap on episode 17. I hope you found that interesting. I had a lot of fun designing the spindles. That was a major task for the project. I think I said in a much earlier video that, you know, with a big enough hole in the floor, you could get any transmission or transfer case to fit, but getting the front diff and getting the front spindles is really the technical challenge of the project. So it's very exciting to have the spindles done. They fit in the car. Everything seems to work. I am just tickled with how they look and the fact that they're only 1 pound heavier. I also showed the new custom struts. I'll go into more detail on that in a future video. This already got pretty long, but basically with lowering the car 1 inch and then also raising the strut mount 3/4 of an inch, there basically was no travel left with the stock struts. And so I worked with a company called Ground Control, and they basically made me, you know, custom struts, or these strut housings with inserts. And so the top of the strut is actually 1.6 inches shorter, exactly what I need for my travel. And then you can see in some of the earlier parts of the video and the pictures, the bottom of the strut is also raised up a little bit to clear the CV boot, and that's going to work out just fantastic. But I'll go into more detail on the front suspension at a later date. So that being said, thanks for watching. I hope you found it interesting. And like and subscribe, and please give a big thumbs up. If you have any questions, please comment below. And on the next video, hopefully I'm showing you the completed oil pan. We'll see how this goes, but that's the next major task, is the oil pan and diff mount, which are really the same thing. So once again, thanks for watching, and have a good one.